Bismillahirrahmanirrahim. Assalamu alaikum dear students. You are watching Study with Sheraz, and in today's lecture we are going to discuss about the properties of alpha, beta and gamma radiation. In the last lecture we discussed about the radioactivity and the discovery of radioactivity, and in that lecture we discussed that Rutherford was the person who classified the radiations from radioactive elements into three categories that were alpha, beta and gamma. So this was the experiment of Rutherford through which he classified the radiations into three classes. Basically he used a lead block in which a radioactive source was placed and he applied the electric field in the path of the radiation, and he observed that the radiations produced from the radioactive source were divided into one of the three categories. One group of the radiations were deflected toward the positive plate, the other group of the radiations were deflected toward the negative plate, and one group of the radiations went straight. By the use of electric field and observing this deflection, he concluded that the radiations that were deflected toward the positive plate were having the negative charge, and whereas those deflected toward the negative plate were having the positive charge, and those radiations that went straight had no charge because they were neither deflected toward the positive plate nor they deflected toward the negative plate. So here we are going to discuss in detail about the properties and about the nature of the alpha, beta and gamma radiations. So first of all, we are going to discuss about the nature of these radiations. Alpha rays are deflected toward the negative plate, and it shows that these are positively charged radiations. Rutherford and other scientists worked on the composition of alpha radiation, and they concluded that the alpha radiations are actually the helium nuclei, but they are having the 2-unit positive charge. If we talk about the beta particles, they are deflected toward the positive plate, showing that they are the negatively charged particles. And many scientists worked on the composition and the nature of the beta particle. It was discovered that the beta particles were fast moving electrons, and this was shown by the E over m value of the beta particles. If we talk about the gamma radiations, they were not deflected toward any plate, showing that they are neither positively charged nor negatively charged, and they are basically the electromagnetic radiation. EMR stands for the electromagnetic radiations with very small delta. It means that the wavelength of the gamma radiations is very small. That's comparable to the X-rays. If we talk about the velocity, so alpha particles move with the velocity of 1.4 to 2 into 10 raised per 7 meter per second. If we talk about the beta particles, they move with the 2 into 10 raised per 8 meter per second velocity. And if we talk about the gamma radiations, the velocity is same as c. You people know that what is c? C is the speed of light. That's a constant quantity. If we compare the velocities of these three radiations, we come to know that the alpha particles are having the least speed or velocity and gamma particles are having the most. So why this is happening? This is because the mass of alpha particle is highest among all the three types of the radiations. The next very important property of the radiation is the ionization power. So what is ionization power? It's basically the tendency of a radiation to remove electron from the atoms or molecules with which they interact. So intense ionization is caused by the alpha radiation. Why? Because the alpha radiations are having the largest mass and charge among all the three types of the radiations. As I mentioned earlier that these are the helium nuclei having 4-unit mass or the 4 AMU mass, and if we talk about the charge, their charge is +2. And if we talk about the electrons, they are not having the mass, or you can say their mass is negligibly small, equal to the mass of the electron, and their charge is unit negative charge. And if we talk about the gamma radiations, they are not having charge, they are not having mass. So beta particles cause low ionization, whereas the gamma radiations cause least or no ionization. The next point is the penetrating power. Keep in mind that ionization and the penetrating power are two factors that are inversely proportional to each other. They are inversely related. If a radiation is having the greatest ionization, it would be having the least penetrating power. And if a radiation is having the highest ionization, it would be having the least penetrating power. So alpha radiations have least penetrating power. They can be stopped by the sheet of the paper, because I have explained earlier that they cause intense ionization. Their mass is greater, their speed is less, so they cause the least penetration and they can be stopped by a small or thin sheet of the paper. Beta particles more penetrating as compared to the alpha particle, and their penetration is 100 times greater than that of the alpha radiations. Why? Because their mass is small, their speed is large. They can be stopped by the 3 mm lead block. So a 3 mm thick lead sheet is required to stop the penetration of the beta particles. And if we talk about the gamma radiations, they are highly penetrating radiations because there is no mass, no charge, and their penetration power is 10 to 100 times more than the beta particles. So they are even more penetrating as compared to the beta particles, because beta particles are having certain charge and having negligibly small mass, but the gamma radiations are having no charge, no mass, and they can be stopped by many centimeter thick lead block. So they are the most penetrating radiations among all the three types. The last one is the luminescence. Luminescence is basically the glowing effect of the radiations on striking the any sheet, or you can say any screen or any photographic plate. So alpha particles cause luminescence on zinc sulfide plate. Basically, zinc sulfide plate is a photographic plate or fluorescent screen, and they cause luminescence on the zinc sulfide plate. If we talk about the beta particles, they have a little effect on the zinc sulfide plate, and if we talk about the gamma radiations, they are having very little or negligibly small effect on the zinc sulfide plate. So this was all about the properties of the alpha, beta and gamma radiations. If you have any question related to this video, you can post your question in the comment section. We will meet in the next video. Up till then, Allah Hafiz.